Hi everybody, in this video we're going to talk about overlapping events. If you didn't watch the first video in the series about disjoint events, you probably want to go watch that first because this one's a little bit more difficult, okay? And so what we're going to say here is overlapping events are two events that can occur simultaneously. So I'm not saying that I'm going to roll two die at the same time. I'm simply saying that I'm going to look for two outcomes, and those outcomes could happen simultaneously. Okay, the disjoint event, just to review, the disjoint, we said like a 2 and an odd number. See, I can't roll a 2 and an odd number at the same time because 2 is not odd. But what if I had a 3 or an odd number? How would that change things? Or in this case, this example, what is the probability that I either roll a 5 or, that's the main word there because that means we're going to do some addition, right? Or means add. I roll a 5 or an odd number. Okay, so here's what I want to do. Let's first look at the odds that I roll a 5. What's the probability I roll a 5? Well, there it is. There's only one of them, right? So there's a 1 out of 6 chance that I roll a 5. Now we're saying, because of the OR statement, we're saying there's actually two ways that I'd be happy. I'd be happy if I rolled a 5, but I'd also be happy if I rolled an odd number. What's the probability I roll a 5 or an odd? And so if I go look at the odd numbers, and let me put a square around the odd numbers, okay? So there, I could roll a 1. I could roll a 3, or I could roll a 5. And when all is said and done, I know that there is a 3 out of 6 chance that I could roll an odd number, right? So it looks, in other words, very similar to this. I got a 1/6 and a 3/6. Last time with the disjoint events, we looked at it graphically and we said, well, really that gives me 4 possible choices that would make me happy. That's 1 out of 6 plus 3 out of 6. So that's where we came up with this formula. The problem here is, you might see, that I only end up with 1, 2, 3 things circled here. So somehow I'm combining 1/6 and 3/6, and I'm only getting 3/6 out. So it must not be as simple as just addition, right? And the error occurs because of this guy right here. We don't want to double count, okay? We don't want to double count the 5. Just because it's in both categories, we shouldn't count it twice. It doesn't add an extra event that makes things happy, right? So our answer here, we can see graphically, should be 3 out of 6. Or 1/2. Let's talk about how to get it. So we come up with this formula, and here it is down at the bottom. For A or B, and I can use this formula for disjoint or overlapping events. I can use it for both situations above. All I do is I simply take the odds individually. So I say, okay, what is the probability that I get 5 or odd? Okay, so A is 5. That's the probability of rolling a 5. Plus the probability of rolling an odd, minus, and this is to account for the double counting. Right here, this last section gets tacked onto the end. What are the numbers? How many of the situations meet both requirements? They're 5 and odd. And what that last little piece does, like I said, is it accounts for the double counting. We'll take off all the ones that have been double counted. So what are the odds, in this case, that I roll a 5? We got a 1 out of 6 chance, right? What are the probabilities that I roll an odd number? We could say 1/2 of the numbers are odd, but I think it's easier to call it 3 out of the 6 for this case because that gives us a common denominator. That's really easy to add those two together. But then we're going to subtract off all the ones that are both 5 and odd. That would be this guy right here, right? There's only one situation that's 5 and odd. So if I take 1/6 plus 3/6, so I'm now up to 4/6. But then I subtract the 1/6 back away, I'm left with 3/6. Now we're not going to state it as that. We're going to go ahead and reduce it, so I really shouldn't say that. I should say 1/2, okay? But that's how we get the 1/2. We can see that half of the choices are either 5 or odd. Now, so I said you could use it for both of these, and that is true, okay? We don't necessarily need this last part all the time, do we? Okay? So notice really what happened in this first problem. And I'm going to go back to disjoint events for just a second, okay? When it's not possible for both of these to happen at the same time, see, the probability of me rolling a 2 and an odd number, a 2 that's an odd number, that probability is 0, right? So really, what we did here is we did this same formula, and we said 1/6 plus 3/6, the probability of the 2 and a probability of an odd, but then we ended up subtracting 0. So in other words, one of the key things to note that this will equal 0 for disjoint events. So hopefully that makes sense. In other words, when I see the word or, I'm adding together individual probabilities. If there's ever a situation where I can double count, where the two things can happen simultaneously, I take off all the ones that have been double counted. And that's how we use overlapping events. The last video that I have for you, maybe 2 videos, I don't know, it depends on how long they get for you. I'll just work through a few examples that are going to kind of help solidify ideas so you can do the homework quickly and easily.